Okay, let's see. Let's see what's on Hacker News today. Oh, wait, let's answer some comments in the Discord. Hold up, hold up. Okay, yeah, I guess we're going live, so it's all good. That's on there. All right, let's see. Finley is hiring engineers to build fintech infrastructure. I kind of want to read this one. Let's see now. First continue hatching condor chicks. Huh. Intel extension for scikit-learn. Not really interested in that. Ryzen Nintendo. Okay. Ooh. 20 terabyte NAND HDDs. Okay, that's cool, but I'm not sure I'm interested in reading that. The high cost of software in the 1980s. That's probably interesting to read. Freelance, seeking freelancer, blah, blah, blah. Not interested in that. The state of Haskell. Oof. Haskell is like one of the first scripting languages I learned, actually. Or I should say functional ones. I'd be interested in that. Surprisingly limited. Quest for optimal solutions. Okay, I'm actually curious on. I want to peruse this one. The state of stablecoins, or should we call them shit coins? all right. Let's see. Executive summary. Stablecoins are digital assets that are designed to maintain a stable value of relative to national currencies. Today, stablecoins are used in the United States to facilitate lending, trading, or borrowing of other digital assets, primarily on digital asset trading platforms. Okay, proponents believe stablecoins could be widely used by households and businesses as a means of payment. If well designed and appropriately regulated, stablecoins could support faster, more efficient, more inclusive payment options. Sure. Moreover, the transition to broader use of stablecoins as a means of payment could occur rapidly due to network effects or relationships between stablecoins and existing user bases. This is a not fucking thing. Says, oh, it could possibly grow in the future. Not a thing. Not an argument, dude. Okay, they have represented a variety of risks. Sure. Speculative digital asset trading, which may involve the use of stablecoins to move easily between large platforms in decentralized finance arrangements, presents risks. Yep. To market integrity. Investor protection. Yep. These market integrity, investor protections encompass possible fraud and misconduct in digital asset trading. Yeah, including market manipulation. Yep. Yeah. I think this is telling us exactly what we already know. Complex relationships and significant amount of leverage. There may be risks to the broader financial system. In addition to digital asset trading platforms and other participants playing, funding assets, liquidity. Okay. So basically, this just okay. This is like thank you, yes, thank you. We kind of already know this. I'm kind of curious, like, what exactly they want to do about this. Finance concern, financial integrity, anti-money laundering, counterterrorism, and proliferation. I mean, the whole coin was designed with the use of like, hey, don't track me, which is great for criminals. So like, what the hell are you gonna do? In addition to market integrity, investor protection, and illicit finance concerns, the potential for the increased use of stablecoins as a means of payment raises a range of prudential concerns. The stablecoin issuers do not honor a request to redeem a stablecoin, or if users lose confidence in a stablecoin, the issuer's ability to honor such a request runs on the arrangement that occurs that many result in harm to users and a broad financial system. Okay, I think it's acknowledging the systemic risk from all this, what's it called, from the Bitcoin and stablecoin ecosystem affecting the actual financial system, okay? Furthermore, the extent stablecoins are widely used to facilitate payments, disruptions on the payment chain that allow stablecoins to be transferred among users could lead to a loss of payment efficiency and safety and undermine the function of the broader economy. Okay. The potential for stablecoin arrangements to scale rapidly raises additional issues related to systemic risk and concentration of economic power. Okay, fine. So what are you going to do about it? Okay, this one. President's Working Group, along with FDIC and OCC, recommend Congress acts promptly to enact legislation to ensure that payment stablecoins and payment stablecoin arrangements are subject to a federal prudential framework on a consistent and comprehensive basis. Okay, they're actually recommending doing something about the coin ecosystem. Fair enough. Yeah, so they're actually developing to be a type of financial instrument. Whoa, hold up. They're financial instruments They don't say they actually have value. The key thing here is that they actually don't say that stablecoins actually have an inherent value. They're just saying that they're a financial instrument. This is I think this one's caught my eye. Yeah. To address stablecoin users and guard against stable runs, sure. Payment system risks. Okay, sure. Make sure that the shitcoin you're not shilling can actually honor the what's it called? Honor the actual payment agreements. Okay. I think this paper is interesting, at least at the beginning. I think that this is pretty easy to read just based looking at this. And I'm just skimming through it, but this is pretty easy to read. I think I would read this later or tonight. But the market capitalization of this is actually kind of nuts. Holy shit. Yeah. Percentage of stablecoin supply is locked in Ethereum contracts. Yeah. So basically, like, a lot of these coins are tied to U.S. currencies. So the question is whether or not these platforms can actually pay whatever is floating around in there. So if we look at the market cap, and these are supposedly stable coins, that basically means that almost like $127 billion of US dollars is directly reflected into the stablecoin ecosystem. And this is actually this is pretty interesting. Imagine like all the money that's floating around the world, and 150 billion of it is like literally locked into stablecoin. What the hell, you know? And judging this rise based on this exponential growth, this is actually a pretty big concern, because suppose that what happens if the entire market cap of coins is equal to like the daily volume of dollars, you know, then, and everyone decides to trade in their coin for dollars. What the hell is going to happen then? You know, you take all the money supply out, you take basically all the money that's flowing around out of the economy, and then you get fucked. So I think, yeah, the regulation is right here. The question, I don't believe the SEC or Congress or anyone will actually do anything about this. But I guess I'll drop this in the chat if you guys want to read this. Okay, and then this one. This one was this one's interesting. A open source MongoDB alternative, and they call it MangoDB. Okay, that's really cute. That's really cute. Let's see what this actually does. Let's actually see this. Mongo SH, sure. Show database. Used to do. Switch to to-do database. So I guess they're showing the table here. Database task find.sort. Okay, so this is like some kind of query. Okay. Interesting. Yeah. So okay, this is interesting. It's not really any different than MySQL, but it's like, I guess the language that they're using here kind of reminds me of like JSON. Actually, you're plugging a JSON formatted query, but then that's gonna get interpreted underneath. So my hunch is that this, I'm not sure if MongoDB actually does this as a query language, but I suspect there's a lot of abstraction going in and out of Mango. So I'm kind of curious like how this actually works underneath the hood. So MongoDB. Yeah, I'm very curious to see how MongoDB works. Does MongoDB work? Okay, this documentation. Okay, some cookies. How does a collection differ from a table? MongoDB stores its data in collections. The collections hold more than binary serialized object notation. Okay, so it's just binary instead of JSON. Documents are analogous to records or rows in a relational database. Each document has one or more fields that are similar to columns in a relational database. Okay. So my question is, when would I use Mongo over anything else? Yeah, actually, Mongo SQL. No, Mongo doesn't have SQL, but you have your own query-rich language, which we just saw was probably like akin to JSON. Because a single document can contain data that would otherwise be modeled as a separate parent-child in relational schemas, MongoDB's atomic single document operations already provide transaction semantics that meet data integrity needs of the majority of applications. One or more fields may be written in a single operation, including updates to multiple subdocuments and elements of an array. The guarantee provided by Mongo ensures complete isolation as a document is updated. Any errors cause the operation rollback so the client will receive a consistent view of documents. Okay. So basically, MongoDB is mostly just for writing documents. And you have a bunch of collections as well. My question, I still don't understand how exactly you would go about actually using this. But you know what? I guess while we're waiting, let me see if our client is ready. Okay. Well, maybe not. Okay, I don't know what Finley is, but Finley actually was trying. I think on Hacker News they said they're actually looking to hire a 10 years forward. As teens left Facebook, it planned to target 6-year. What? Excuse me? Excuse me? Okay. Facebook has a demographic problem. Even before investigations revealed that the company's products were destroying teens' mental health, interest in the flagship product was dropping off a cliff. Sure. Teen usage of the app declined by 13%. Aging up is a real issue. Sure. Holy shit. Holy fucking shit. The company is making a major investment in youth and spun up a cross-company virtual team to make safer, more private experiences for youth that improves and their household's well-being. Holy shit. This is really not good. What the fuck? Alright, hold on. Let me get my client on the phone. Give me a sec. Oh, hello? If you're talking, I can't really... I can't... Hold up. Hello? Oh, give me a sec. Let me see. I can't hear you. Can you hear me? I don't see any of your voice coming through. Oh, by the way, like you're not lighting green.
You hear me now?
Yep, I can hear you.
Oh, you can hear me now. That's
Yep.
good.
Hey, what's up?
I'm gonna just, I'm gonna just, I'm gonna just paste my questions in the chat, and then if you could just read them one by one, and then you can just answer them.
Yeah,
I
sure,
feel like
sure,
that'd be more.
sure. So you're basically asking about, since you made it to the final round of a new grad Google position, and then you have some questions. So the first one is, how do you supplement EPI with grokking and LeetCode? So I think I answered this in the guide, but basically, grokking is really meant for you to understand like the basic patterns of what you might actually face or what you might actually use
Mhm.
in a interview. So for instance, one of the ones I like using is like the sliding window. And you know, there's a lot of variations of it, like rolling hashes as well. Those are built off sliding windows. You know, two-pointer techniques for arrays, and so on and so forth. And so the point I'm trying to make with grokking is that this is the first step. This is just like the first step in all the other things that you need to do, because not every single question is going to have a pattern available for it, right? And so this is where EPI
Mhm.
comes in. EPI actually helps you in actually formulating your thoughts and in a way that allows you to grow from a what's it called? A hold up. Let me disable. Let me mute this channel for a sec. Okay. So basically, what I'm saying is that EPI will actually show you how to actually improve your thinking, in the sense that you don't go from, oh, just throw a pattern at it and then you're done. What it actually does is that it'll actually show you not just like what the answer is, but it'll give you a very brief step-by-step through how they got the answer and why it works and why this is optimal. And a lot of the answers themselves are pretty well written, including the code as well. So there's multiple layers to it. So once you've mastered the basics of like with grokking, then move on to EPI in order to really improve your thinking and approach. Because ideally, you would be able to do every single problem in EPI and get, their answer. But of course, that's not always possible. So EPI is very good at like, hey, this is what you're missing. This is like, if you thought of the question this way, or if you had this insight, you would have been able to do it. And this is where you really start flexing your problem solving muscles. And then and then leak code is really meant as a spot check, because leak code is not very consistent in its approach or results. So I don't recommend leak code as like the first thing you start off with. So if I miss a problem, should I go look at the solution and immediately solve it again, or just move on and come back to another time? I say give a problem a fair shake, and if you can't solve it, look at the answer and really, really dig into why you didn't get the answer. It's not so much like, oh, if I had iterated from the the left to right instead of right to left, or something like that. It's almost always there's a train of logic that you can follow from your own thinking to their thinking, and it's really knowing like what you had to do in order to do that. It's not because these ideas like, oh, I should have iterated from left to right instead of right to left, like stuff like that, like random magic bullets don't exist. They come from somewhere. They usually come from somewhere, and really what you need to be able to do is find out like what it takes in order to go step by step and then get there, and then after that you can think about, oh yeah, well, what happens if I could, what would I have to do to get it faster? Are there steps I can skip? It's really just analyzing what it takes, that train of thinking that you follow. Does that make sense?
And how long should you spend, like, before you should give up and then just move on?
I give myself 45 minutes.
Okay.
Right now, you say you're moving at a very slow pace. How long should you take to finish grokking? It ultimately depends on when your final round interview is.
So it's in 5 weeks.
I think you can probably start merging in EPI into your thinking, but you should be almost done with grokking at this point. So, like, I don't do every single problem, and I don't recommend everyone do every single problem unless they're really struggling with the pattern. But once they like get it, then just go to EPI straight up. I would say even now is like a good time to start EPI. But how long do you have?
Okay.
How much left of grokking do you have?
So I just got it like a couple of days ago. So I just finished 2-pointer, and I mean sliding window. So I'm about to do just 2-pointer and then BFS and DFS, and I think I'll just supplement EPI with that.
Okay, so you literally just got it a few days ago. So it's not so when you say very slow pace, no, like of course it's gonna be slow because you're just starting out on it. So I would say give it some time. Give it another 2 weeks or so.
Like how many topics should I be finishing a whole topic in one day, or should I be doing like 2 topics
No,
it's
quality over quantity.
I mean, but there's at a certain point, like you probably should be moving faster, because like what if you're doing like 3 problems in one day, you know what I'm saying, from like sliding window only, or like, you know what I'm saying, like.
Okay, so can you solve those 3 problems? Or do you understand the
yeah, you can understand them, but you're not, but there's like more sliding window, you know what I'm saying? I guess I see what your point is. Like it's better to understand the concept really good than trying to finish it as fast as possible just to finish it.
Yeah. And what you're describing to me is, oh, I just need to get through it. Like, no, what's the point if you don't understand it at all and you can't execute on it?
Yeah.
It's like,
gotcha.
Yeah, like what's the fucking point? That's what I don't get. So if you're taking too long, then it's like you take too long. That's it. Because you can always push back the interview, but you only get like 1 shot every year or something like that. So.
True.
So I'd rather you take a very, very good shot than to say, oh, I prepared really badly because I rushed through it.
Okay.
Yeah.
And with EPI, how would you supplement that with grokking? Like, so I'm talking about like, so like if I did the sliding window, should I just go ahead and do arrays and strings, like
Just
random problems in arrays and
finish grokking,
strings?
then do EPI. I wrote that in the guide.
Okay, all right, gotcha.
Okay. If I have a lot of time to study, should I be trying to finish grokking as fast as possible and move on to LeetCode Premium? Grokking's are base building blocks. I think the most of your
Okay.
questions are coming from, oh my god, I don't have time, I don't have time. Then make time, push back the
Yeah.
interview, and then, like, cause
I
you're
mean,
basically
how far can I push it back?
you can push back however the fuck you want, man. Like, usually within reason, of course. You could say, oh hey, like, you're. I assume that you've planned this for like end of December, but you could say, oh, I have vacation or something coming up. Can we push it to January? Then you have a full winter break because and you're worried about like you don't get a fair shake because developers, engineers are like they want to go home and go on vacation, and maybe that you want a better chance. You can make that argument.
Okay, I'll try that. I mean, I just don't want her to like feel like I'm not interested in the role, so like she
Worst
resends
case is that
the.
they say no.
Yeah, okay, I see what you mean.
And from their side, it's like they want a candidate to have the best shot, because it's expensive to hunt these candidates down and then to book them for on sites, not just from your time but or their time. It's also from the company's time. There's basically engineers. It's 8 working hours engineers are spending interviewing you and going through your
Hmm.
documents and resume. And if they can save that amount of time just by and making sure that they hire you, and you just are asking just for a little bit more time to prepare, they'll replace you with someone else, dude. Don't worry about it.
Mm, gotcha.
So, like, yeah. And then for some of the problems in grokking, should I have a brute force and then the optimal solution? You should be able to derive the optimal solution. Like, ideally, what would have happened is that you can explain, step by step how you go from brute force to optimal. But you should just be able to hit the. But when you go to submit, it has to be right the first time, and it should be the optimal one.
Okay, but like, what about in the interviews like session? Like when I'm doing the interview, should I have automatically just like if I know the solution on top of my head, should I just go to that solution, the optimal solution, or should
Derive
I
it.
go through the
To
process?
play it safe, derive it. So let's say, hey, the
Okay,
initial naive solution, the one that will give me an answer is X Y Z. But if we optimize along X Y these axes and these, and we realize we're using too much space or too much time, then we eliminate this, and then we get to this answer.
okay. So every time I do a problem, I should always have the brute force, then I should go into the optimal after that.
That's the rule of thumb. But 10 chances are there are multiple iterations, so you don't have to go through some of the obvious brute force solutions. But yeah, just use that as
Okay.
a rule
Do
of
I have
thumb.
to? I don't. But I don't have to implement the brute force most of the time, do I, in interviews? Like
Not really. You
if
just have
the
to
brute
explain
force
that.
is obvious.
You just have to acknowledge it.
Okay, gotcha.
You have all day to solve problems. How long a day should you be spending? As literally give up everything else in your life. It depends on how important this is to you. If getting a Google position is super important, then you're gonna give up time with your friends, free time, everything, except for like bathing, sleeping, and eating.
Mm.
So
It's
it's
just, but at that like at a certain point, like how are you efficiently like studying? Like, are you like getting the concepts as you know what I'm saying? At a certain point, you're like diminishing return.
that's
I
up to
feel
you.
like
That's up to you, dude.
okay,
Like it's how hard you want to work for it and how badly you want it. Because my
I'll
philosophy is
work hard.
yeah, but what I'm hearing from you is that and based on the tone of the questions and what you've been asking, you're trying to get away with the least amount of work. Like,
Mm,
how do I put in the least amount of time to get the most That's what the sense I'm getting from you. And you're free to correct me
mm,
if I'm wrong, but I'm guessing that's kind of like where your mind is headed.
yeah, I guess. Yeah, you could say that.
Yeah,
Like I'm trying to find the best like way I can approach this, like, without having to like, burn myself out or something. But like I guess there's no other way. Like I have to like put in the work and just, put my head down and just do the work and then
yeah.
whatever happens on the day happens.
Yeah, exactly. So when that day comes, do you want to say, "Oh, I should have done more?" Or do you want to say, "Hey, I
Hmm.
did everything I could. I've given up everything just for this one thing that could change my life."
Hmm.
Who do you want to be?
Yeah, you're right. The second option, of course.
Yeah, exactly. It's like even if you fail, you just say, hey, I give up everything. I did everything I could, and it didn't work out. No regrets. But if you decide to be lazy about it and said, "Oh, I'm gonna go hang out with my friends this week. Oh, I'm gonna go see this girl," instead of like go work for a fucking new grad position at Google, you know,
Mm-hmm.
and then it's like, "Oh, I should have done this," you know.
Yeah, that's true. So you're right. So I should finish grokking, then do EPI. All the problems in EPI. Would you recommend that?
There's a if you watch my streams, I point out there's a little schedule on top of the book. Go by that.
On the is that the Google sheet that you had with the grokking
No, it's a PDF.
on
It's in the PDF.
it's the P.
There is yeah. Watch
Okay.
like the past three like last week's streams. I do it for both of my
Mm,
clients that I'm on that have streams right now. And there's a little section in the book that says here's the study schedule. Like these are the problems that you need to do at minimum. But personally for me, I try to do every single. When I was doing this, I did every single problem. Um, and if I
okay.
didn't write the code for that, I at least did the pseudocode for it.
Okay.
Yeah.
Okay. Cool.
And like I said, it
Gotcha.
doesn't take very long. If you put in the quality work, like literally 50 hours, 50 to 100 hours of quality work, and
Hmm.
like you'll hit that in like 3 weeks if you put in
Yeah.
quality time.
Exactly. Yeah.
Yeah. So just take your time, go slow, really understand the pattern, know it backward and forward, understand like what happens if you misuse it, understand your and really get work on
Hmm.
your problem solving, and then you'll be surprised. You'll surprise
Hmm.
yourself what you can do in 3 weeks.
Hmm. Okay. One more question. So, if let's say I did like four problems for the sliding window, like if you don't get it on the first try, is that like after you did like let's say if I did the first two sliding window problems and I
Mm-hmm.
didn't get them, and then I should probably get the gist of it after like the third or fourth.
Mm-hmm.
You know what I'm saying?
Yeah.
But if I still keep missing at on my first try,
Then
is
figure out
it
what you're doing
like
wrong.
is that okay?
That's it. It just means you're doing something wrong. Figure it out.
Gotcha.
All right.
All right.
Anything else?
No, that's it. If I have any other questions, I could just hit you up on this Discord and ask you a question.
Yeah, ask anyone in the main chat. There's plenty of people who
Okay.
have gotten offers as well. I can always I can always drag them in the conversation, or you can look at any of the people
Mm-hmm.
who log in with like the L3, L4 roles, and then you can ask them directly if you really want to.
Okay. Awesome, man. Thank you so much for your time, man. I know you're busy.
Yeah.
I'll let you get back to your stream.
All right. Thanks, man. Take care.
Yeah. Bye.
All right. Bye bye. Holy shit. All right. Let me go ahead and bring my next client on.
Recording in progress. Hey, hello.
Hey, but
Hey, how's it going?
good. How you doing?
Doing good. Yeah. So catch me up on like all the things that you've done this weekend.
Yeah. So, like you already know, I wasn't able to do much this weekend because I was flying and stuff. But I did try to squeeze in some practice time.
Mm-hmm.
I did try to. I did practice on a couple questions after our session on Thursday. and some on Friday. Didn't really get to do much on Saturday, and then I did a couple problems yesterday. I did, however, spend a good amount of time reading DDIA. And I know the last thing you told me to work on was asking logical questions. And that's what I tried doing. But I guess like, for certain questions, I guess I was like able to slowly kind of find out like what's next to ask and like see like what's the inefficiency, and kind of from there go from there and ask the next logical question. But sometimes like with certain questions, I just simply do not know what to ask, or even when I do know what the efficiency is, I'm not exactly sure what question to ask next, if that makes sense.
Okay, give me, show me one of your problems that you did, and I want to see that.
Let's see. Okay, let me. Okay, yeah, I think I can share my screen and show
Yeah,
you.
go ahead.
Oh, can you give me the permission?
Oh yeah, hold up.
Yeah.
All right, go.
Okay. Right. You can see my screen now, right?
I'm waiting for it to show up. Okay, yeah, cool, got it.
Yeah. I think this one was one. It's basically next grader element 3 only code. It's kind of like a array slash string problem.
Okay.
With a bit of math.
Hold up. Let me look at your study schedule.
Yeah.
I don't think I asked you to do leak code.
Okay.
Do array recursion of strings.
I was trying to do like certain prompts from array from API, and then like I would jump on like to do like 1 or 2 questions. That's kind of how I was.
Okay.
I also had some questions I need to add on to the diary that I just did on locally, but this was one of those questions where I was like, I was able to get like decently far. I guess like based on what I had, it was like pretty much like half the solution. But the one part that I was really missing was doing the reversal on the second half of the number, like the string after swapping. And like I like had a lot of examples that I kind of listed out, and I tried to generate like meaningful examples. But I guess like when I submitted the code and it didn't work as expected, I was like kind of confused. And like even from there, like I kind of saw that like it's different from what I had, but I wasn't sure like what exactly I was missing. So like eventually I did figure out like with a hint from the solution, but I guess at that point when I was doing it myself, I wasn't really able to deduct like what's the next question to ask when I got stuck.
Okay, so wait, let me read this question. So, given a next positive integer n, find the next smallest integer which has exactly the same digits existing in the integer and is greater value than n. Okay. All right. Yeah, got it.
Yeah.
And then your basic algorithm would be swap. What did you decide to do? Go from backwards using mod. What would describe your algorithm in plain simple English to me?
Okay. Basically, I would start backwards, and I would find the first element that is smaller than the elements we have seen starting from the back. Like the first descending element,
so
if that makes sense.
So you went from right to left instead of left to right?
I went from right to left, starting from backwards.
Why'd you go right to left instead of left to right?
Because if we want to find because we want to find the smallest integer that is greater, and I like had a couple of examples that I kind of listed out, and I realized that to get the next greater element, I had to basically have to swap like the greatest an element with a smaller element from the right side. Yeah. So yeah, I had like a couple examples, and then I basically got to this point where it was like basically finding this smallest permutation. I would start backwards, and I'll find the next less element.
Okay.
And then when I do like some swapping, I realize they do work. And
okay. By the way, your example's wrong. By the way, the first one is 2543 should translate into 3. Was it? Shouldn't it start with 3, 2, 4, 5?
Oh no! This one I was like kind of doing it in the middle, and I was like realizing I had to swap and reverse and stuff. But
okay, but I understand your algorithm.
Yeah.
Anyway,
yeah.
So what is the confusion here?
I think like I did the swap, and then I didn't really like think like I thought like my examples would be enough, and then like I submitted the solution and it didn't come back like accepted. And when I like look at the like the rejected answer that they gave, and from there I like built up a little more examples, and wasn't quite sure like what exactly it was, although it was like very intuitive. Like it was like basically just reversing the second half. But I think like at that moment, like I was just like not able to kind of deduct that.
Right.
If that makes sense.
Yeah, this basically is one of those questions that I call stupid questions, because it's not about your understanding of a problem. It's like really whether or not you notice that pattern in the examples or not. And you can do as many examples as you want, but it's like if that idea never crosses to you, then it's kind of like, what the fuck, you know? So this is what I call a stupid question. I would never ask this. I know that Facebook loves asking this question. No, Google asks this question. I call it a stupid question because it doesn't test your problem solving ability. But even if you got most way through, I think most people would give you like 80-90% credit. My question would then be, what would it... And then you said, oh, what does it take for me to get over that? And you said, oh, I needed to reverse all the digits. Well, then the working backwards, it would be, well, what did I have to know or figure out in order to actually... in order for me to actually get this insight and execute on it. And the only way I'm familiar with this problem, and the only way I see it is that you would have had to look at every single example and look for that specifically. Yeah. That's like the only
and I think
and that's a random shit, you know?
Yeah. And I think like the question I should have asked was like in just like in a very broad and general sense, is like given like a number, and if you like swap the biggest element, how would you ensure like the second half, or like the right part of the number is smallest? And the answer would basically just be like have it sorted. I think like I think that was the question that I missed asking myself, even though like you mentioned, it is kind of a stupid question. But I think like if I had asked that question, probably would have covered and get it done. But I was like mainly interested because like, I was doing like stack prompts. So I started with like the next greater element 1, and then 2 and 3, and 1 and 2 were pretty much like array prompts, and using a monotonic stack. So like that's why I wanted to practice it. But then when I got to this one, it was like a totally different approach, and that's why I kind of got confused. But yeah, this is one. And then as for things outside of practice, I did talk to the Amazon recruiter today, so I'm gonna have to get back to the recruiting coordinator and give her some dates to set up the on-site.
I do want to say though that I understand that your vacation should have started is potentially Monday through Sunday, but losing it a weekend is pretty bad, especially 2 weekends. Like 2 weekends is really, really bad.
My vacation ends this Saturday, so I could do this coming Sunday. But yeah, totally, I do miss it a lot of time.
Yeah, I'm gonna expect you to work double hard over the next few weeks then.
Yeah. Okay. Makes sense.
Yeah, so don't dick around like that. All right, anyway. So with that said, let's actually go ahead and move on. Let me see if we can keep pushing on this idea of going down logically, or if we need to work on something else. After your vacation, we'll start talking a little about system design. But for now, let's consider this like our like we're gonna really still try to drill as much as we can on this idea of thinking logically. How good are you with your recursion, and do I need to talk about a dynamic programming with you yet?
I think recursions, I did meet up with Carl and kind of talk about that. I think with tree problems, I'm able to kind of visualize recursion a lot better. But if it was like a recursion on, say, a dynamic problem, especially on arrays, I think that's where I may struggle a little.
Okay. Let me see if I'll give you, let me test your quick recursion, and I'll give you a brief rundown of dynamic programming afterwards.
Okay.
But it's not really that difficult. So let me go.
Yeah. As for grokking, I've done the knapsack ones and the Fibonacci one. I just haven't done the remaining two, because I think there were like the longest sequences and like the subsequences problems like that. Yeah.
Okay, but that's the thing. You need to be able to do grokking on your own. But I might as well just say right now, the bottom line is that dynamic programming, all it is reusing previously calculated states and combining them together.
Yeah.
And when you actually go through something like the coin change problem, with like, let's say for instance, it's the version of the coin chain problem that says, hey, yeah, you can have an unlimited number of these coins. Then all it is really, the state really just boils down to how many of coin A did I take, coin B did I take, coin C did I take, right? Because if you take coin, let's say I take one of coin A and one of coin B, right? It doesn't matter which order I took them in. All I know is that I've entered the state where I've taken one of coin A and one of coin B. And then go, and essentially you can structure that decision as a decision tree and then just combine those states. And then once you understand like what states you're combining, then you essentially have your dynamic programming solution. All that's left is to convert from that tree form all the way to actually the array form. That's it.
Yeah, I think with dynamic programming, I think once I am able to come up with like a naive solution, it's typically easier to convert to the next like optimization.
Yep.
Compared to other types of problems, because I think DP is kind of set up in a way like if you have the naive solution, it's easier to spot like where you can optimize, whereas like some other types of problems that conversion may not be as easy.
Yep. All right, so I'm gonna give you the same problem I gave him, the serialized and deserialized problem. This one actually, yeah, this one's gonna be good, because then I can use both of you to compare. Because I'm pretty sure you're gonna run into similar issues as he did. So let's see. Give me a sec. All right, here we go. So I want you to serialize and deserialize the general NRA tree.
And an array tree. So I could have more than one children, right?
Correct.
Okay. And let's see. And there's no restriction as to like how exactly I would do this, and I could just do it in any way I want, right? As long as I'm able to serialize it and deserialize it into the same exact tree.
Sorry, repeat that.
It doesn't. There's no restriction on like how I do this, right? As long as I'm able to serialize this and deserialize it into the same tree.
Yeah. No restrictions. Basically, whatever you put in, you need to get out.
Okay. Okay, let's see. Children A has root A has B, C, D. Okay. So with trees, we know that we have three ways of traversing it: pre-order, in-order, and post-order. If it's just a regular binary tree, I would do pre-order. Now with this, I kind of want to, so let me actually list out like how it would look like if I were to traverse it pre-order. Pre-order is starting from left and then root and then right. Is that correct?
Pre-order starting, yeah, pre-order is going to be starting from the one you visit in left in children.
Okay. Let's see. If I start at A, I would basically go down. If I were to go with the left side, I'll go B, and then go E. At E, I basically have okay, N array tree. With tree problems, I kind of like to picture what do I do at the current node or the current node. Sure. So say if it was just a simple node, if I'm at E, then I should just basically return the root, and there's nothing there. I'm just kind of picturing how I would serialize the null values, because n array, it could go up to any amount of children. Let's see. And if we were to do, let's say, parentheses, if I have one parentheses for each child, I think that might be something that I could kind of work on. So say I have something like this.
Okay.
And basically at this point, I would know that if we were only looking at A, B, C, D, then I would know like this node has 3 children. And if we were to go into B, let's actually try this out and see how this would look like if I were to expand on it. I'll have E and F. C would then have nothing. So let's just say it's empty. D would be I, G, H, J, E, and F. E, F. Okay, let's actually space this out a little. Okay, I think it will look something like this.
Okay.
So yeah, I think because earlier with the comments, like it's not really clear what children they have. But I think if I separate like each node into a bracket of its own, it's actually a little more clear.
Okay, so then what about where's K?
Yeah, so this is where I'm about to add it in.
Okay.
So if we were looking only at F2K, it would basically just be this, if that makes sense. And then if we were to go one level up at B, E, F, K, then let's see. Yeah, this would be the string. So say if we were giving this, the input as this, then we would basically end up with B, E, F, K. So yeah, I think so. Okay. I think this currently looks fine to me. And basically, if okay, so if I'm given a string and there's no brackets after it, I can assume that this this node has no children. So for example, if I'm given E, just like that, I know that it has no children.
Sure.
But if I'm given this part, then I know that F has one child, one child. Yeah. So let's see, how exactly would I do this? Focusing on the serialization part. Okay, I know that first one, we are gonna have, the root is gonna basically be, we have to get like the value of the current node. That's gonna be the first one. And then since we have, okay, so if we were to kind of simplify this, for each child, we basically need to get its string, if that makes sense. And we would just kind of append to the existing string that we have.
Okay. So
go
ahead.
So okay. So say we currently at, so this would be, let's see, how do I make it easier for you to understand? So this is currently where I'm at. I'm at root A, and my string would just be A because I only have the value of the current node, if that makes sense. And then A currently has what? Let's not even focus on the children nodes of the children of A. But if we only look at one level down, we only have B, C, D, right?
Yeah.
Does that make sense?
Yep. Don't worry about the copyright.
From
I know what you're talking about.
Okay. So from here, I say I could kind of do like for each child and children, I basically get the child string. I would call the basically the same function, serialize function on child node. And after that, I could kind of append to the current resulting array. I know we have to handle like the nested levels, but this is kind of like the basic.
My question is, what about the rest of the elements? Why are you writing code when you haven't even finished up the rest of this shit? That's my question.
Okay. I guess I shouldn't write it that much like code, but
I don't understand. Yeah, like my question is like, I get you have the first level of the idea, but it's like, why are you committing yourself to it if you haven't tried it out on the rest of the stuff?
Okay, I guess I wasn't really trying to write code, but I just ended up writing. Okay. I'll take note of that
and then before you write a single line of code.
Okay. So at this point, should I like? So yeah, should I like focus on just talking and not writing down much, or should I?
I want you to complete your idea. Like, how do you go from this to this? Like, that still hasn't been made clear to me. I mean, I know where
Okay,
it's going, but it's like I need to know you know.
Okay. So we would start with like, so this would be kind of like my result. So initially, when I'm at root A, I would just kind of add the current node
Okay.
to the string. So this would be basically represent the string at the current node,
Okay.
and it doesn't necessarily mean the final answer of the entire tree. But say we just add root node A, we
Okay.
basically have the string of the value, and then for each children, we want to add its string into the current nodes array.
Okay.
Or current nodes array that I would eventually turn into a string.
Sure.
And so say this would be child B's string,
Okay.
and this would be child C's string and child D's string.
Okay.
And because here I'm not really wrapping my current nodes string in parentheses, when I get this return value, I would want to wrap it in this parentheses, and same goes to C and D. And so when I'm at, so I would basically traverse through all child nodes of the current nodes children, and I would call the recursive function on B. So say we are now in, so this would be like a recursion tag. So I'm currently at node B. Is that clear?
Okay.
And
So
I would then
I see what
process.
you're doing. You're taking the result of whatever your function is and then plugging it in here.
Yeah.
Okay.
Yeah.
I see.
And then in the end, yeah, and then because I'm going down like the tree, eventually, so yeah, to kind of better demonstrate, I would just kind of type it out. So here I'm at the B node, and I add the current node's value into the resulting array, which is the same as what I did up here.
Okay.
And I would then compute the children nodes. So it only at the current node B we have E and F. So we call it child E string, and then child F string. If that makes sense.
Okay.
Okay. So now all the way when we go down to E,
I get your idea now. I know what you're trying to do here.
Okay.
That's fine. Now that you've drawn out the idea and you're showing what to do, all right. Now I'm satisfied. You can do whatever you want.
Okay. Okay. So yeah, at this point, so this is sufficient explanation if I were in an interview.
I mean, I would say yeah. Now that I understand what you're doing, I'd be like, okay, well, how are you gonna do this? Treat this right now as if it's an interview. So.
Okay. So at this point, would you want me to maybe start talking about the serialization part, or should I focus more on like finishing this first half of the?
It's up to you.
Okay.
I'll tell you what I would have done later on, but right now this is your interview.
Okay. Okay. Just to be complete, let's actually go through how we would actually deserialize this, if that's okay with you.
Your call.
So say I end up with. Sorry, what was it?
I say it's your call.
Okay. So say we have this current string, right? In the deserialization function, we will kind of apply the same logic on what we did in the serialization part. We will basically take the first element of the string and initialize the current node. So we know A is current node. And then we would have to traverse the rest of the string, grab each highest level bracket, and create the child node. What I mean by highest level bracket here is when I'm looking at this string, I want to be grabbing this pod, this pod, and this pod. So I wouldn't want to like kind of stop here, if that makes sense.
Okay.
So one naive way to do this is that when I hit a left parentheses, I can kind of start keeping track. So say I'm over here, when I hit the left parentheses, I could kind of keep a second pointer, and all the way when I hit another right parentheses with zero balance of left parentheses, I know this entire part is going to be one child.
Okay.
Okay. And from there, I could kind of call the function on that particular string, and that should return me that subtree. And then I would then continue with the current string. But this would be not very efficient
Mhm.
because we do notice that if I were to do this, we then go into B, right? We then go into, say, if I was just processing this part, say I go in there, then I know when I hit the first left parentheses of E, I would then do the exact same thing. I'm basically just going again and again. So I'm trying to see like what is a better way to deserialize this without repeating that same pointer, moving through these same elements. So let's see. When I'm here, I want to be able to find the next one. Let's. I'm trying to see if a stack would be useful here. If I were to add the elements onto it. I'm just gonna see how a stack would help out. If I were to add B, okay. Once I hit left parentheses, I add B onto it. Would that help? Let's see. Then I continue. I hit a left. I would do the same thing. Then I hit a right. I would then kind of pop this. Yes. Let's see how that would work. If I were to pop E as a node now, and then I would continue to F. Okay. I pop K as a node. I guess, how would I keep track of the parents if I were to do it this way? Yeah. At least in terms of, like, I feel like this would be quicker if I'm able to traverse it without going through the same elements twice or more. But I'm trying to see how I would keep track of the elements' parents. Let's see. I was at K. Okay, what if it's the previous element? So if I was all the way back here, I pop E out. It would basically be B's child, but how would I tie that back? Let's see if we if I look at the stacks top element, let's see if I create a node of stacks top element. So when I pop this off, gonna be, if I were to continue, let's see how this would work out. At F, I add K as I continue. I hit a right parentheses. I pop K as a node, and then it would be a node of the stack's top element. So that would be F.
Okay.
I continue, right parentheses. Now, because F I've already initialized as an element, I don't want to do that. Let's see. Is it safe to assume that the inputs values are going to be unique?
Sure.
Okay.
I mean, I would say,
guess
actually, you know what? Let's make it interesting.
Yeah.
What if it's not? What if, but I would, like, for instance, if I had A in one node, and then A in another node, consider those two different nodes.
Okay. This wouldn't affect how I serialize the problem.
Okay.
I'm just more so thinking how I would deserialize it, because initially I was thinking, like, if we were guaranteed unique values, in order to at least kind of tackle this issue of not knowing if I already created a node for a certain value, I could kind of use a hash map.
Oh, no.
But if we were given duplicate values, let's see how I would do this. Okay. Let's see. If I were to, okay, let's actually go back here. When I hit a left parentheses, I add the element right next to it into the stack. So hitting left is fine. Now I'm just thinking, I'm just kind of figuring out like how exactly I would handle this situation when I do hit a right parentheses. When I do hit E,
I can see
I know
that
E is
you're
going to be
struggling
typed.
with this. So here, let's put a pause
Yeah.
in here. At least
Okay.
write out the code for the serialize function first, for me.
Okay.
Just so I know that you can do it. That's it.
Okay. Let's see. Going back up here. These. Okay. So I'm just gonna write out kind of like pseudocode or like basically steps of how exactly I would do this.
Sure.
Sure. I would have a obviously top level function that will call a helper function that will basically do all the heavy lifting, aka recursion. So the helper function would take in, would take in current node, and it should just return a string. And okay, so so initially in the helper function, the current, I say current string, or we could just say string, would just be, I'll make it an array now so that in the end we could kind of join it together. And we basically do the first thing is we append the current node's value into S. And then for each children in S.children, we basically call the recursive function.
Okay.
It's a helper function on child, and this will give us that child's string.
Okay.
And then we can append kind of left parentheses plus child string plus right parentheses into S.
Okay.
Does this make sense?
Sure.
Okay. And then once we're done with everything, we can basically just return S. Does that sound good to you?
Oh. Sorry, I'm typing notes. Okay, sure. So, okay. So then, all right, sure. Yeah. Why not?
Okay. So we have class solution. Like I said, we kind of have a high level. This is going to be serialized ordinary tree. We're given a root node. And like I mentioned, I'm basically just going to call the, I'm just going to call it helper here.
Mm-hmm.
And then it's going to pass in the root node.
Mm-hmm.
And here I'm going to write helper node. Okay. So going back up, I'm just going to kind of repeat what I mentioned. So I'm going to have S as an array.
Mm-hmm.
And let's see, I guess we could also do a quick sanity check here. If the current node is empty, we can just simply return an empty string.
Mm-hmm.
Okay, now that we get here, we simply append node.value. And here in the input, I'm given A, so I'm assuming that the value is string, so I'm just appending to it. But in the case that if we were to give it integers, we can always just convert this to string.
For now, it's fine.
Okay. And now basically for children in S.children, I get child string.
Mm-hmm.
equals self dot helper. Let's see, child node, and then I'll basically do s dot append plus child string plus that, and yep, and then in the end I would just return dot join string. Let's see. Yeah, I think this. Let's actually run it through the example.
Okay.
Is that okay? So we're given the tree. Let me paste this down here so we can see it over here. Assuming this is what I want in the end. So I start at A, and S would currently be just A in it, and then I would call. So A's children are gonna be B, C, and D. So I'm just gonna call it on B now. And over here we have B, and B is gonna then call E and F. So I'll get E over here, and I'll get F. Let's see. Actually, let me make this. Let's see how I make this clear. Let me separate it out. So I will call E and F from B. And F would then call on K because F has one children. So we only have, so K doesn't have any children here. Let's see, we would then immediately return it. Okay, so we would return K. So when we call this helper function on K, it's simply just gonna return this string. Is that clear?
Yep. Because you only have a K.
And then and then I would at this step when I do s dot append left parentheses plus child string plus right parentheses, I'm just basically going to end up adding this to the S array of node F.
Sure.
And because E is has no trend, I'm just going to simply return this. So what I'm gonna end up having here is going to be E as well as F, K. Yeah, does that make sense?
Yeah, I think generally I know how your algorithm works. I think it's fine. Just going through that one example kind of already proves it for me. I will say let's run with this one, right?
Okay. Yeah.
Time space complexity. What's the and there is something inefficient about it. Before we go back to the deserialize.
Okay. Let's see. Looking at this, I am indeed kind of processing each node once, I believe. So I'm at A, I call B, then I just pass into E. Okay, in terms of processing nodes, I am processing them once per node. But I'm guessing if there's any, let's see, inefficiency, what would that be? Is it because I'm repeatedly building the resulting string? Let's see.
That's half of it.
Yeah.
There's another part to it.
Okay. So yeah, well, let's actually, so that is definitely one inefficiency I see, because I'm actually like joining, I'm like returning this and which I have to join it, which is over here would be 2, and then when I come back to B, I am doing that same exact operation of joining it.
The join is not the problem. There's another problem.
Oh, okay. Let's see. Like, I guess the only thing that would look kind of suspicious would be the appending left parentheses and the right parentheses. Is that
No, okay, I'm about to just tell you, just let's take time.
Okay.
It's the memory. It's like you're constantly allocating and deallocating memory. It's not that big a deal, considering that assuming your memory. Let's assume that, garbage collection would pick it up, but let's assume job collection doesn't pick it up. It should because of the stack, but you will end up like in a situation where each time you're creating you're allocating another block of memory each time you call this helper function. So essentially use twice as much memory as you usually would. almost.
As opposed if I were to do it iteratively without recursion stack.
No, it's not. It nothing to do with that. It's literally just because you keep, each time you go into a node, you're creating a string, right? Well, an array of
Yeah.
strings, right? That's your You're creating the strings and then an array of strings. It's another allocation, and then when you return, you return back a string. So it's basically this allocation is kind of wasted.
Okay. I see what you mean. So
It's this allocation that's just kind of wasted there. It's not a big deal, but it's like important to acknowledge that.
I see. Okay, that's definitely something I need to work on. Would you say like, okay, say if I were not to return a string, right? Would it make it more I'm just curious, would it be more efficient if I were to return an array and then at the original function, the call function would just kind of extend its current array?
I mean, if you're talking about returning an array, sure, but then that kind of messes up your whole weird structure because now you have an array of arrays that go on, down the road. But it's whatever.
Okay.
I just was hoping that you'd acknowledge that, but whatever. So let's finish up the deserialize. At least we got the code for the serialize.
Okay. For the deserialize, let's go back to where we stop at. Okay. I'm just gonna put this back up. So I'm basically still at the point of deciding what to do when I get to your right parentheses, because I'm kind of in the idea of exploring using a stack. Okay, so I'm at E. Let's see. Okay, if I were to create E as a node, okay, say if I have a temporary array, let's say I'm just like storing it aside, how would that work? And then I go to F, then I go to K, I pop it, let's see, if I were to add it to this, to pop F as a node, I now need to make sure that it has K as its child. Let's see. I'm also thinking like if there's any reverse logic I could kind of use from what I have in serialization. Let's see. Okay, seems like a stack wouldn't be the best approach, at least based on what I'm testing out here. It doesn't seem like a stack would work with this.
I mean, it looks like it could.
Okay.
It depends on how you do it.
I'm gonna try to. Let's see. Okay, I'm gonna simplify this problem just for my own sake.
Sure.
So if I were to have a string of just A and then B, C, D, you get that this is C wrap in parentheses. If I were to use a stack in this, okay, I would basically need, okay, so I would always have first element as a node. Let's see, what if I set parent as A? I want to basically have BC. So popping B as a node. Okay, I guess the stack works if it's like a very simple case like this, but when I do add something like this, let's see. If I could work with this subtree, I think in general it should work for the other subtrees. Just like how we did with the serialized problem.
Okay.
Okay. So we know A. Okay, so I have A and I set the parent as A. Okay, then I have B. I get to E, it's a left parentheses, I add it in there. I get to the end of it. Okay, I still have to pop it.
I mean, you don't have to do it as a stack. You can also do it recursively if that helps.
Recursively. Okay, so if I were to do it recursively, that means when I hit a left parentheses, I have to recurse on it. Let's see. I see. Okay, I'm not quite sure how this would work out, but like something is telling me like I could do something like if I were to hit a left parentheses and do a recursion, I would just keep doing it like as so, and then actually let me type this out so I can explain it a little better. When I hit a right, I would just basically initialize the node and return the node. Okay, so this is kind of like the idea I kind of have in mind, but let's actually see how this would work out. So we start with this first left parentheses before B, and then we would kind of recurse it on the rest of the string, right? Okay, B, then I go in, I hit the parentheses before E, I will go in again. Over here, I continue iterating through and I hit the right parentheses, and I know I want to initialize the node and return the node. So yeah, that's kind of like the basic idea I have, but I'm trying to see like how I would manage the state.
Okay.
Let's see. If I were to do recursive, let's see. I also have to keep track of the, I guess I would say, indexes, so I don't end up going through them again.
Okay. Yeah, that's true.
Okay, let's write down what I have. Left parentheses. I recurse. Right parentheses. Initialize and return. Node. I guess what we do want to return as well. Possibly index. I'm just gonna put that here as well. And we would continue iterating the string. Well, I guess this also boils back to the original approach I had. Like if we were to do this in a naive way, I could obviously just kind of keep calling recursion the moment I hit a left parentheses, and then kind of keep going. If you remember, like my first naive solution. Okay, I'm still thinking like how exactly I would kind of optimize that by using indexes. Let's see. Okay, if I were at here, I initialize. Let's see, not even that. Left parentheses, I go in. Okay, if I iterate through the string starting from 0, when I hit B, I'll even hit D. Okay, say I were to do recursion on the string starting on index of this before B. Or we'll start at index of B. Then we will basically be doing a problem of. I'm trying to see like how exactly I would like. if I'm able to kind of just pass this in, then I'm good because I could just kind of continue traversing it and pass in each top level bracket. But in order to get that, like I would basically be doing that naive approach of like
you said.
recounting it
Yep.
again and again. Yeah.
Yeah. So then, what's your other option?
Yeah. So my other option is to actually pass in the entire right side of the string.
Sure. But there's also one. Instead of making a copy of it, you could also
pass in the index.
Yeah, you can pass in the index that you're at, and then
So that's why I mentioned recursion on the string, starting on index, because I do intend on passing in the index.
Or you can have it exist as a like outside the functions as like a global variable if you really wanted to.
Outside the function as a global variable. Yeah, like that definitely works. I'm just trying to see like how I could incorporate that into what I currently have.
Okay, I'm gonna give you like 3 more minutes and then we'll discuss.
Okay, I'm just gonna continue to try to hammer this idea and see where how far I can go with this.
Okay.
So if we were to pass in the index of b into the equations x, so say I'm trying to see how we keep track of you. So say stack would be kind of like actually, so I'll go into b. Okay. Actually, let me clarify. So when I'm giving a string, I'll first initialize a node with the first value, if that makes sense. So first value of the entire string right now would be a. I would do this first. So, actually, yeah, I'll put this up here. And then once I'm done initializing it, I would kind of start iterating through the string. And then, like I said, like when I hit the left parentheses, I would then recurse on the remaining part of the string. And then when we get there, we would basically do the same thing. We recurse on index of b. First thing we would do is initialize a node with the first value. This would be b. Continue. Then I would call this recurse if on string e. Okay. Then I basically initialize node e. Okay. I guess like if I do hit a right parentheses, I could just return the current node. Let's see how that will work. So I initialize node e. Then I return node e. So if we are keeping track of the indexes here, I would kind of pass in as well index of right parentheses after e. Okay, and then so we're back to basically this level of the call stack. So we were initially at this parentheses and we pass it in. Now that we get a node and a value back, I guess I would have to, so when I get basically what? Assign the return node as current node's child and update index. Return index. That makes sense. And then from here, I would go to F, and then I would basically do the same thing. I would recurse on F, initialize node F, and then I would continue. I'm gonna not type it out if that's okay. I'm just gonna talk about it using the highlight in the interest of time. I hit this left parentheses of K. I go in, I recurse on K, and then like I said, if I hit a right parentheses, I'm just gonna return the current node. So as well as the index of the right parentheses. So going back, I'm gonna be at this level of F. I pass it in there. I'm gonna update the index to the right parentheses now of K, and K, I'm gonna assign it as a children of the current nodes. I'm gonna assign it as the current node's child. And then update the index, I continue, I hit the right parentheses again. And at this point, the current node is going to be B. I'm going to return B. So at that, and as well as the index of right parentheses, then when I get back here, I'm all the way at the top level of the call stack. I'm going to be actually back here. But now that I have the index, as well as the return node. I'm going to assign B as a child of node A, and I'll update the index all the way here, and I'll kind of repeat the process as for C and D.
I think you got it. Yeah, I'm gonna pause the timer. I'm just for the interest of time. We're gonna stop here. Tell me what you think you did right, and tell me what you think you did wrong. Like how you felt doing this.
I think like the entire problem, like I think I'm not sure if like I did well, but I think what I liked or that I appreciated that I did was having the recursion stack and like just like writing out like what it will look like at the current call.
Mm-hmm.
That definitely kind of helped me clear out, kind of basically help me visualize how my algorithm would work and if my solution would actually work for the input. I guess what I didn't like was like I was trying to like go through the examples, but like I mentioned, like I think the first part was what you did mention was me trying to write some pseudocode before like I even had like the idea proven to work.
Yeah,
that was one thing. And then I think the second thing was like being indecisive as to if I should code out the serialized portion or move on to solving the serialized portion. I think that's where I was like I didn't like that. I kind of hesitated on that. I felt like if I already had a pretty clear idea of like what I want to do with the serialized part, at least like you mentioned, it may not be the most optimal because I'm doing the allocation, but the idea at least does work, and we did run it through. I feel like I could have just coded out, and it would just probably take like a few minutes, like when I actually did. Before moving on to deserialize, at least that proves to the interviewer that I've solved like half the problem. And then I guess like working on the deserialized part, like I think like using a stack was like a good like intuition, but then I kind of got hung up on like doing it entirely iteratively, even though because I was using a stack, and I didn't really think about like, okay, what if I kind of use the idea of a stack but not as a actual variable, but instead as a recursion stack. Yeah, I think those were the things that I noticed, but I'm not sure like what else you noticed.
Yeah, that's a good summary of it. Basically, let me paste my notes in here. We can kind of go over it. So, here. So first of all, I think you start off okay. I think what was a little bit weird was you start off saying like pre-order to post-order. To me, like put these vocabulary words are buzzwords unless they have, and they're meaningless unless you put an idea behind them. So what I mean by this is that it doesn't matter if you use pre-order, post-order, or in-order traversal to solve this problem. What matters is that you solve the problem, and then you describe the order in which you actually traverse them with the vocab. Now, this is just a little nitpicky thing, but that kind of clued me into like your thinking of like, oh, I need to like use these fundamental concepts in order to solve the problem, when really you should be a little bit more, I would say a little bit more flexible, a little bit more open to solving the problem first, and then identifying, hey, yeah, I can use this pattern to fill in where I need. It's a little bit of doing things in the reverse, but yeah.
So it's actually kind of funny because like when I was actually doing the problem, I wasn't really thinking of like pre, post, or in order, but I guess like I just at that point, like I guess like in the context of an interview, I just wanted to like let the interviewer know like what I usually think tree traversals would have. But I think like I don't know if you noticed, but when I actually started doing the problem, I wasn't even caring about like I would do left first, right first, or root first. But yeah.
I noticed that you didn't care. That's why I'm like saying it's not a bad thing, but it's just like keep an eye out on that in case it shows up again. All right. Next, because like I also write down you could have been doing this with BFS as well. But yeah, the idea is like why the hell did you jump into code? That was like what the fuck there. And so you spent like basically 4 minutes fleshing out the idea, and then let's go for the deserialize first, so I can actually talk about that idea first. So then after, let's say it take you 12 minutes to go from here to serialize, and then after that you went from that to here. So let's say like this is another like 5-6 minutes, no 8 minutes. So basically it takes you about like 20 minutes to get to the first idea. A little slow for my taste. I would have liked 15 minutes, but I think part of it is like context switching. Part of it is you not really like, I had to I spent some time steering you away from it. But I think if we shaved off that and then you started thinking a little bit more about the idea to begin with instead of the code, I think you probably end up like somewhere around 18 to 16 minutes. But after that, all it really is after that is just like maybe like let me give you an example. Like this exercise of writing out the pseudocode before the code is more or less just that's what it is. It's an exercise that we do in practice. In reality, like when it comes to the interview, you might not actually need to do this. So I'm going to give you the benefit of the doubt saying that you could probably solve this in 15 minutes once you get to a point where you don't actually need the pseudocode. But I think right now it's still... go ahead.
Okay, I just thought we wanted to write it out. So in the context of an interview, say if I was like kind of showing through my example with the recursion callback here, and I kind of explain what I would do, is it fair enough for me to kind of skip writing this entire part and just starting over here? Is that what you mean? If you have a
very clear idea of what you wanted to do.
Okay, and if I do not, I should still kind of write out maybe not entirely this, but maybe like just the gist of it. For example, I wouldn't even write about like the top level or helper function. I would just say like, okay, like my main function is just gonna be, I'm just gonna be focused on pretty much this, but I would just kind of simplify it into like, I'll have a current array and I'll append the current node's value into the array, and then for each children, I would call that same helper function and add on to it, and I'll just return that. Would it be something like that instead of, okay.
Yeah, I think that's fine. The reason why I make you do this is so that way you get things down to a very plain English explanation. I'm not expecting you to write so much detail that it might as well be code. I'm trying to get you to explain things like like you would talk to a 5-year-old child. So in this particular example, I would say I would iterate through every single, for every node, I would add that node's value. Like actually, I'll write out visit node, add node's value to array for every child in node's children. I would say something like recurse into child, get back string rep of that node and descendants, add parenthesis, I would say add parenthesis around it, around the str rep, and then add rep to array, and then and then return the array to string. This is literally all I would write. Now it's the same amount of lines as yours, but it's like literally the same idea, except I don't give a shit about this. I don't give a shit about this. I'm literally just saying the very, very bare basics and in a way that is very easy for the interviewer to understand. This is why we do what we do. I ideally like your pseudocode to look more like this rather than like this. Because it keeps things very simple and easy. And I think and I get why you're doing this. You're basically still in that mode of like, oh, I'm still thinking of things in code, but I'm trying to express it more like English. So I want you to get to a point that you can do things like this.
Okay. Okay. I do notice the same thing during practice. Like when I'm writing out pseudocode for my idea, like I write it and I look at it, I'm like, this is almost like code, but then it's like what's the point? Like it kind of I see it during practice as well.
Yeah, but now that you see this, the way I'm writing it is like it's nothing fancy. It's kind of like sloppy even a little bit. But the reason why it's not is because it compacts every single one of your ideas in here, right? Helper function should take in current node and just return a string. Well, I kind of express that with like visit node and then return array to string. So I'm already encapsulating that idea. Append node's value into s. Yeah, it adds node value to array for every child. We basically call it, this is like a nothing. This is a nothing burger. Like, what value does this add?
Wait, sorry.
Like, look at this. I'm bolding it. What value does this add?
I think this part I was just trying to. So this part that you voted, I think I was trying to basically say that I would get back the string representation of the node and its descendants. But I didn't really. I feel like I wrote more, but I wasn't as explicit as you were.
You're saying more of nothing. That's really it. And that's the problem. I want you to be very efficient about your discussion. Now, it can look like fucking garbo, scribble, gibberish, like what I do, But the point is that it actually gets the idea across very, very succinctly and very easily. There's not a whole lot of effort that I need to put into reading something like this.
Yeah.
And I want you to get to that point. If you can get to this point where you can literally express your ideas very simply, but still compact all the ideas very efficiently in here, then you know you can get yourself off the pseudocode. Like, I don't need to write this, but I do it as like a pure exercise. I want you to get to this point.
Okay.
So that's the next thing. And I think if you get to, once you get to that point, then it gets a lot quicker and you'll get to that 15-minute benchmark. The next thing,
Okay.
let's go back to the,
I do have,
go ahead.
I do have one question before we move forward. So say I'm at this point of like, I'm about to write this code, this pseudocode that I wrote out, right? And I know that, okay, what I currently have in mind is this, and I know that it's kind of like too much of nothing, like you said. So should I like kind of take a pause and not immediately start writing and see how I could shorten it to get straight to the point?
Or should I like? Sorry, go ahead.
Yeah. I'm just not sure. Like in practice, or like during an interview, like if I'm at this point of like I have an idea of like this is what I want to write, if I should want to take like that additional pause to think about how I would want to write it in a efficient way of like how, like for example, how you did it.
Yeah. So in practice, when we do things in practice, I would say, yes, try to shorten this up. Definitely. Like say, oh, how can I write this faster, better? How can I get the high level idea across in a more simpler way? When it comes to the actual interview, you're probably not going to do this. You're probably not going to even use the pseudocode. But the idea here is that whatever you do here, you should be done in like when you practice these problems, because it will help you get in that mode of thinking.
Okay.
So I want you to do that. So the pseudocode is going to you need to update that. But I think if you spend like literally a good week on this will become very natural. If you focus like very specifically on this.
Okay.
This will be very natural. Okay, so let's go back to the notes. Next thing, deserialize. Okay, so for me, like I think like you were mostly spending like 10 minutes bouncing around the ideas. I think that's fine, but then you spend another like 10 minutes kind of realizing that you needed to manage the node dependencies, and so you were like, and you're realizing it was getting a little bit messy. So this is where like it becomes a little bit I would say a little bit more of a recognition thing. So what you mentioned before, going back to what you were saying, you said, hey, I need to pass in this chunk of the string from open to close. Well, like you said, you recognized immediately that that was not efficient. So, but then you should have recognized that you could have used the indices to tell you whether or not to go in, to go, and what to do. It would end up becoming like a finite state machine, essentially.
So that's where I like was like kind of stuck, because I don't know if I mentioned it clearly, but when I talked about recursing it, like I'm looking back up here.
Yep.
So I was saying like I would when I hit the left parentheses, I would then have another pointer that traverses onto the first balance right parentheses would be here, and I would actually be passing in pointers. But the point is I am passing in pointers and not reconstructing the array or the string.
Right.
But the inefficiency is that I'm having the pointer count through these indexes again and again. And even though the final solution is also using a pointer, but I guess like because the naive solution or like the inefficiency had something to do with pointers, I was trying to stray away from that, and I guess that kind of blocked me from getting the final idea without the hint.
Yeah, so basically you got hung up on your own ideas. That's something that I can't really like, how do I describe it? I'm basically telling you, hey, yeah, man, don't freaking do that. Like, don't get hung up. But it's hard for me to do that without, it's like if I tell you to do something without telling you how to do it, it's kind of like not helpful. But that's kind of the thing here. Like, I like you need to get out of this mode faster. Like, just recognize, know when to give up. Know when to give up on your idea. Now, you know that, you already knew that, managing all these different pointers is going to be really fucking messy, right? But it's like knowing to give that up. It's like, it's not necessarily wrong, but there's some part in that answer that the multiple pointers, that means, hey, there's something in here that gives me the answer, the solution. We just want to get rid of all the unnecessary crap. That's it. So in theory, yes, you could recurse into a pointer here and then just like find some way to exit out as well. But you're just like creating a bunch of pointers. Essentially, you end up with like, you end up with 1 plus summation to log n, which is like n number of pointers.
It's pretty bad.
Yeah, so it does get pretty bad. So instead, I think you should have just like retried like, how do I do it? Scan it. So instead, you could have just used like, instead, why don't I actually use an actual stack? And when I go into a a node here, I could push the previous node onto a stack, and then once I'm done creating this node, I pop out and attach it to the element in the back of the stack, and then pop it out of the stack. That's another way to think about this. And I think if you had to spend a little bit more time thinking about, like, oh, how do I use like one pointer instead of two? I think you might have come up on the solution as well. But I think it's knowing, it's like you kind of got, like you said, you got hung up on this multiple pointer idea, so then you tried revising it into, you got stuck into that to go into recursion, and then you tried doing your recursion without the pointer, which is not necessarily a bad thing either. It's more or less the exact same thing like I described. And then you kind of realize that at the end. It's just a question of how do I get there faster?
Okay.
That's really what ultimately up to, but you at least got there. That's the key thing. So at least next you need to freaking you need to basically just get there faster. That's all I'm gonna say. But at least you solved the problem, which is better than what the other guy did. So you know what, like at least good job. I'll say that.
Okay, thanks.
All right. But it's like definitely would have liked you to do it faster. So all right. So with that, I think your recursion is okay. I'm not gonna say it's like good. I would probably rate it like 6 or 6.5 out of 10, 7 out of 10. So you definitely do need a little bit more practice, but I do also want you to do the pseudocode, but I know we're limited on time, so let's do this. So let's write your to-dos for now. Get your pseudo code to a point where it's plain English sentences. That's one. The next one's gonna be get your let's say work a little more on recursion, know your optimizations, because I get the feeling that you don't actually look too much at elements of programming interview and try to figure out the optimizations. I think once you get an answer, you just kind of like do a very cursory evaluation of it, but you don't actually dive deep into like, oh, this is the thought I needed to have in order for me to get to the solution faster.
I definitely like one is like I don't do that enough. You're right. But then second, like for the few problems that I did try doing it, I just like it like I look at it and I know like which part I'm not optimizing. But like the API but also doesn't explain like how it went from that realization into the next optimization that they had.
That's up to you to figure out.
Okay.
It's like not everything's gonna be in the book. Like it's not the end all. Like there's no resource out there, like maybe other than me, who would probably be able to explain that to you.
Okay.
Because it's not worth the paper it's printed on. Like fundamentally, if we're talking about like value, most people don't give a fuck. You know, most people just want the answer and move on. So it's like they're not gonna print it. That's why you got to do the work. And once you put in the work, once you figure it out, like I would say probably the first 20 problems, it's just like it's so easy. It'll be easy and very apparent to you.
Okay.
So really put some work into the optimizations. And you know, this is probably okay for you to do. Like, this, I know you're on vacation, you can't really spend too much time. So why don't you do this? Like, as for your homework, go back over past problems, look at the naive solution that you have and the EPI optimal. Spend like 10 to 20 minutes reverse engineering the path it takes from your solution to theirs. You can put in like 2-3 hours a day, right?
Okay. Yeah. No. Yeah. That's fine.
Yeah. So at least for the first few times, spend some time on this, and then at least try 1 or 2 problems. Can you make Thursday replay?
Yeah. I can still make Thursday replay.
Okay. I want you to do this. So your homework is going to go back over past problems to do this. You're going to basically, and then pseudocode.
Okay. For replay, do you want me to do you want to go over like a video of me trying a new problem, or do you want me to kind of show that go over past problems, or I could just record both and see if we have time to go through?
Yeah, let's do both and see which one you have time to go through. But your homework is going to be also redo the old problems, but then do it in a more pseudocode fashion. Like literally.
So I don't want to write code.
No, I want you to just do the problem, but then like those ideas that you have, I want you to try writing the pseudocode as simply as possible. Like say, oh wait, this is like so what's it called, so messy, too much like code. Let me write things in plain simple English so that way I know what it's supposed to look like. And then do the same exercise. Like, what did I write that was not necessary? What did I need to add? I really want you to get into this habit of like be efficient with your words. I really want you to do this.
Okay.
Okay.
Yeah, I always have that like problem of like worrying that if I'm not constantly saying something, like I don't want to be like stay silent that long.
Uh-huh.
And sometimes like I don't take the time to compose my sentence before saying it, if that makes sense.
Yeah, I get it. I get the need to like, oh, keep talking.
Yeah.
Just say it's really be efficient. Every single word you say matters. Because otherwise, I don't know whether to
Okay.
ignore you because you're thinking and blabbling out loud, or like saying stuff. And you kind of showed here at least you were thinking out loud, going step by step through your process. That's fine. That is efficient. What is not efficient is for you to like say random stuff that doesn't make sense.
Okay.
And so if you really do feel like you need to talk, at least talk through an example and say, hey, this is what's right with it, this is what's wrong with it. Yeah, just saying stuff just adds noise, and I don't want to hear noise. If it's you just saying, hey, I'm going to run through this example, I'm going to go in and out, it's like, okay, fine. I can at least accept that. It's like, it might piss me off a little bit, but it's like, I get it. It's part of you actually going through the actual example in order to solve the problem. That part I can accept.
Okay.
All right. So with that, let's actually, I'm going to give you let's do a dynamic programming problem together. And I want to see where you're at with that. I think this is going to give us the most value for what time we have left. Before we do like update your schedule, because I'm basically assuming between now and Thursday you only have like 6 hours, and then on the weekend you only have like another 6 hours. So I'm basically trying to squeeze in what we can get out of 12 hours of practice.
Okay.
So let's see. So which problems have you done? Which pattern are you up to in grokking for the dynamic programming?
So I bought the grokking DP one.
Uh-huh.
So they have five sections, right?
Yes.
I went through a couple problems in the first 3 sections, but not the remaining 2.
So you went to the first 3 sections, but then you didn't go. Okay, so I want to see your thinking for the what's it called, the problem. Yeah, for the grokking problem. So I'm gonna give you one from there. I want to see how you think about these problems actually. So let me scroll down to. Yeah. I even wrote down before, like, don't get too married to the initial idea. Yeah, I'm looking at the notes from 1028.
Yeah, but then I remember like last week ones. There was also one that was like, don't give up too early.
Yep.
And then, yeah.
I will admit that a lot of these ideas do end up being conflicting in some ways. Don't give it too early.
Yeah.
Like, drive the idea until you cannot drive too much anymore, and once you feel like you've done that to a reasonable extent, then you can give up on it. But it's like, don't be married to it. It's like, date it for a while, and then when you realize it's being an abusive asshole, then just get rid of it. Okay. You know what I mean? It's like, if it no longer serves your purpose and you milked it, then it's like, okay, we're good. You gave it a fair shot. It didn't work out. Move the fuck on. You're not gonna put a ring on it if it's not gonna help you solve the problem.
Yeah.
All right. Yeah. Let me go ahead and give you the problem. So, yes. Okay. Staircase. Yeah.
All right. Are you gonna paste it on the top or
bottom below? So I'm putting it 1030. So you see where I'm at?
Okay. Yeah, I see it.
Okay. So, given a stairs with n steps, implement a method to count how many possible ways there are to take the top of the staircase. Given that every step you can take 1, 2, or 3, right? So, suppose that there are, there are 3 steps, right? There are 4 number of ways to actually get up the stairs, So, and here they've given us the example. So let me actually highlight this in black. There we go. So I want you to be able to do that. I want you to tell me the number of ways. And I want you to go step by step through the process of actually of what you do to solve a dynamic programming problem. Well, let me ask first. Do you remember the solution to this or not?
No, actually, because the third one, which is the Fibonacci sequence, which is where I think this problem is from. That one's the earliest pattern that I've done, so I don't remember much. The more recent ones were the first 2 knapsack ones.
Perfect.
Perfect.
Then I want to see you solve this. I want to see you solve this like with logical thinking. Okay.
So given an state of n steps, implement a method and count how many possible steps. Okay. And we're starting at the beginning. Okay. Actually, it's number of ways of 4. Okay. So I guess like like the first idea that comes to mind is that I want to have like number of ways to reach the top, right? And so I can either take one step. So say I have like if I take one step and it gives like if I take one step at the current position, it would basically give me a number of ways, and then same with 2-step and 3 steps. So like the first idea would just kind of be like compute like the number of ways based on like 1-step, 2-step, and 3 steps, and kind of add them all up to get me the total number of ways to climb the stairs. Let's see, Kevin. I'm gonna write out a couple examples just to see what it will look like. And this one, we will basically just have 1, and it's 2, step 1, 1, 2, 3,
Okay.
1, 1. Okay. Let's see. Okay, I'm gonna go to the next page just to make sure you
Sure.
know where I'm at.
Don't worry. I've already collapsed everything, so it doesn't matter.
Okay, so let's see. So I'm given a number, right? So I obviously like want the same idea I'm having up here, where I want to do 1-step, 2-step, and 3 steps. So say at the current function, or like at the current call stack, we have a n, which is the number. And if I were to kind of call like naively, if I were to call recursion on that number, if say it's like 1-step, I would be like helper function, and it would be n minus 1, if that makes sense. And then 2 steps would be helper n minus 2, 3 would be helper n minus 3. And then, the answer is just going to be 1 plus 2 plus 3. And these are going to be the actual values returned by the function. So let's see, like base case. Okay, if we were to call these, okay, let's see. Okay, base case, if n is 0, return 0, n is 1, we return 1, n is 2, return, let's see, 2. Okay, so if n is less than or equal to 2, we simply just return n.
Okay. Sure.
That's the base case I'm seeing. Now going back here.
Well, I would say if there are no steps, then how many steps do you need to take in order to get to where you need to go?
Sorry, if there are no steps.
Yeah, suppose there's no steps. How many different ways do I need to? How many different ways can I take a step in order to get to where I'm going?
0, if there are no steps.
Why? If I'm already there, then just one way, right? Just stay in place.
Yep.
I mean, it's fine. If you don't see it, then at least you'll see it when you work through an example.
Okay. So you're saying if I have no steps?
Don't worry about it right now. You'll see it when you go through an example. Just focus on the rest of the problem for now.
Okay. Helper minus 1. So I'm like, at least over now, I'm like kind of doing in a n minus kind of situation.
Sure.
I'm just thinking if I were to reverse it and do a start with 0 and do a n plus situation where I do n plus 1, n plus 2, n plus 3 until I reach n equals n.
Okay.
Or like the current number equals to n, would if that would actually optimize it at all.
I mean, you seem to have an idea of what you want to do, so why not just write the code for it? Or unless you're not clear on it.
I have this idea, but I'm not sure like this would work. So let me actually try
test
out
it
with
out.
an example.
Test it out.
Yeah, I think that's the best way for me to know if it works or not.
Mhm.
I'm actually gonna try with a bigger number because that actually works better. Because in a small number it doesn't really make sense.
Sure.
So n minus 5, I'm gonna call 1 is gonna be helper on n minus 1. So this is gonna be 5 minus 1 going in for then I'm going to call 4 minus 1, 4 minus 2, 4 minus 3. Wow. Even typing this out is going to take a while. 4 minus 1, I'm at 3. I would then still have to call 3 minus 1, 3 minus 2, 3 minus 3. At least at this point, I know this is basically going to turn into 2, 1, and 0. So essentially, this is going to be 3. Let's go back up here. 4 minus 2. This is going to give me minus 2 is going to be 2. I simply return 2. 4 minus 3. That just gives me 1. Let's see. In the end, I'll have 3, 2, 1. Okay, so that's at the top level. So 2 would be over 5 minus 2, 3. Okay, I would then do the same thing. 3 minus 1. I would then call 3 minus 1. And this is basically the same as what we have up here. So I'm just going to say total is going to be 3 because we already did this. Minus 2. Okay, that's pretty much it. 1, actually, no. 3 upper is going to be 5 minus 3, which would give me, this would give me 2, and I'll just return 2. So let's see if this is actually the correct number. So all I have is 3 plus 2 plus 1 plus 3 plus 2. So total is 11. Okay, this is going to be a little hectic to write it out. Okay. Wait. Oh, it can only take 1, 2, or 3 steps. My bad. Let's see. This is. Okay, I think it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, it seems like it doesn't work unless I'm counting something wrong. I'm gonna check it one more time.
Okay.
Answer is.
I mean, the very simple test would actually be to pass n equals 3, right? You would know. I already gave you the answer for that, right?
Yeah, I just wanted to test a big example, but I guess like that kind of took
Yeah, why not
a
just
lot
look
of time.
at an example you already know? So.
Okay, let's actually do that. N minus 3. So I would do the same thing where I do n minus 1. So 2 would return 2. N minus 2. That'll be 1. I return 1. N minus 3. That's gonna be 0. So yeah, I guess it doesn't work because the answer is 4. Let's see. If given the state of n steps,
I mean, I literally told you that it was
Yeah.
this is not gonna work. So what do you need to do?
if there's 0 steps, I guess I still don't get what you meant by it. If there's 0 steps to take to reach oh, okay, I see what you mean. Here I'm taking 1 step, 2 step, or 3 step. But if I'm an n, I don't take any steps because I'm already at n, and there's going to be one way, and that one way is to not take any steps.
Yep. There we go.
Okay, so if n is 0, that returns 1. Let's see. Okay, so if I go back to the example I have, you're looking at this example. Can you see
Yes, I
that
can
I'm
see it.
highlighting this?
I can see your highlights.
So okay, so here I do 3 minus 3 is 0, right? And based on my previous algorithm, I'm returning 0. So if I were to do this with n equals 0, I return 1. This would add 1, and I'll get 4 over here. And because this is actually based on actually wait, this one is based on this, so this is going to return 4. So basically, I'm adding 2 more, and my total answer is going to be 39, which works. Does that make sense?
Yeah, I get it. I get it.
So okay, I'm gonna practice the pseudocode that we mentioned. Basically, if n equals 0 or 1, we return 1. If n equals 2, we return 2, based on what I'm having. Otherwise, we would just kind of compute n minus 1, n minus 2, n minus 3, and return the sum of those values. Is this something that would be like good enough in terms of pseudocode?
Sure.
Okay, so
I mean, you kind of already gave
based
it
on
up here,
we-
to be honest. So I mean,
Okay. All right. So obviously, the inefficiency that we see here is that we are computing a lot of these values repetitively. Even based on the example we have seen, like I already know that if value is 3, I have already done this. I don't want to write that out again. So we could obviously we can use memorization by saving the values of current number. So I'm currently passing like n into the helper functions.
Yep.
So if I were to and I know the size of memorize, or basically n would just be an array of size n. Let's say n plus 1, because like if say it was the n was 4, I would basically have 0, 1, 2, 3, 4, which is 5 elements. So I basically do the same thing. I'm gonna go back up here. If n equals 0 or 1, return 1 equals 2 equals 2, and then I would just do, before I actually do the computation of the sums, I'm just gonna check if n has been computed.
sure. That's the memorization. Okay.
Yeah, memorize.
All right.
I just return value from memorize array. Okay, so that's the top down approach that would take. Now, how would we do this in a bottom up way?
I want you to like write the what's it called, the write the array version, the shorthand. You know what it is. So.
Yeah. Do you mean the? Are you talking about like? Do you want me to get the bottom up solution, right?
Yeah.
Okay. So let's see. I would obviously have an array. Let's see. Size would be still n plus 1. And we know. Let's see. Okay. N when n is 0, this is going to be 1, n equals 1, this is going to be 1, n equals 2 equals 2. So say if we have like an array, initially it's just going to be -1, -1, all the way up to n plus 1, if that makes sense. If I initialize this first 3 elements, I guess like moving forward, I could kind of just add from the previous 3 elements, because based on what I'm computing up here, I'm basically doing at the current call, I'm basically computing the sum of n-1, n-2, and n-3. And so if we were to cache it in the DP array, resulting array, we could basically grab the same values from the 3 previous elements.
Okay, yeah. I don't think you need to talk this much. You already have the idea. Why not just write the code?
Okay.
Like I think you talk way too much. Like you already have the idea. You've had the idea for a while. Why not just write the code for it?
Okay. What is this? Staircase. I'm just gonna think of that. Like I mentioned, I'm gonna have a array of link n plus 1. Then we have dp 0, dp 1, dp 2 equals to 1, 1, and 2. Okay. Now let's see. We have to go all the way up to n. Okay, so for I in range, let's see, it's going to be start at 3. We go all the way to n-1, so I'm going to do that because we want to stop it. Okay, since I'm basically going to do dpi plus dp. Okay, this is what I think it will look like.
Okay.
But it's kind of, wait, I'm gonna take a quick look. Looks kind of weird to me for some.
It looks really weird.
Some reason. Yeah, especially with the indexes, it looks kind of weird.
What's going on here?
So if n is 4,
where the heck is this coming from? Where's this n plus 1 coming from?
Yeah, that's what I was hoping to test out.
Okay.
I think.
No,
I think
I'm asking where it's come from. Why did you write n plus 1? Where in your idea did it come from?
Okay. Okay, it didn't come from. This is supposed to be the last computed element, but
Okay.
because I was over here, like when I was doing the loop, I need to add 1, and also because up here I have to do n plus 1, and so like I wrote this, and then immediately after I was like, wait a minute, this looks kind of suspicious, and that's why I like wanted to take that back and just look at it. So initially we have this. We want to return dp of. So if I return 3, okay, that's going to be the right element. Okay, so I'm just going to return n over here. Yeah, that's immediately what I was hoping to kind of test out. But yeah, that's how I think I would solve the solution.
Sure, I think it's fine except for this index, unnecessary. N plus 2. It just needs to be n.
It just needs to be n?
Yep, there's no reason for it to n plus 2. Why do you need n plus 2?
If it's just n, it would stop at n minus 1.
Really? Is it inclusive? Is it inclusive or not inclusive?
No. It's actually exclusive for Python. And
okay.
So I think
it has to be n plus 1 then. If it's exclusive.
Okay, n plus 1.
Yeah. So my question then would be, how do you not like you got it fine? My question is, how do you avoid this little mistake later on in the future? The n plus 1. How do you avoid that mistake?
I think like not writing it that quickly, and like I think like dealing with indexes, I think I had the idea, but I feel like I should have maybe spent like maybe just 2 seconds, like even 2 or 3 seconds would have kind of helped me there. before I write out the actual code.
I would say it's more that
Yeah,
you are
or
just.
should I like?
Go ahead.
Or should I like? Oh, would it be actually doing a one last check after writing it out? Like after you know how I wrote, like n-2 and also like return n+1. I should have like did a quick check before saying like, okay, I think this is the code.
To me, this says either one of two things. One is that you're abandoning your idea that you planned, or two, you don't know how to write loops. I'm more inclined to believe you abandoned your idea.
Like, okay, actually, no, I actually didn't like abandon, but I just like because when this happened, like this was mainly what caused me to write n+1.
Okay, so that means that you don't know how to write loops. Get better at writing loops. That's really it.
Okay.
Okay. Other than that, your approach is fine. I think you talk way too much though. Like, I mean, like let's scroll up. Like you already knew what the answer was up here. All that was left was really to test it, right? And so to me, it's like the most obvious way to test it would have just been to start simple. Start simple. How about the example that is given to you? Like that would have saved you a lot of grief already. Like you didn't have to go through all this, to find out that something fucked up, right? You could just test it n = 3, and I already gave you the n = 3 solution. So if you plug that in, that would have been fine.
True.
And then because of the nature of this, like all you're testing is n-3, n-2, n-1. Then in theory, as long as you go out to the point where you cover where it doesn't need, it passed for n-3, right? So then it could pass for you could test 4 and 5. I think those would have been fine to test. I would only picked one more above that, like 4. Because then you already know that 3 and 2 and 1 are already correct by its nature. So you just need to make sure that it recursively goes into it. Like these are ones, like 3 is the one without a preset, right?
Yeah.
So then just need to have one more built on top of the preset, and then it's all good. It's all gravy, at least in my opinion. And then after that, all you do is just write the code. I think you just talk way too much. I don't know why. Why did you have to figure out like all this? Like you already knew the answer. I think you already knew what to do. So what was the point in talking? That's my question.
So like after I got the n = 0 return 1, are you saying like I'm talking a lot before I got to this point, or even after I got to?
I would say you're talking a lot, but it's like you're talking a lot about nothing. It's the same problem that we had before. It's like you already knew the answer. You already had the answer. My question is, why didn't you commit to it? You could have just immediately wrote the code starting out.
Even without writing these.
I mean, look at what it bolded and look at what you wrote. What is the difference?
Okay.
The only thing that's different is just this.
Okay, I guess like the main thing was just like the kind of like the lack of confidence. Even though I had the idea, like because I didn't write out these steps over here, I wasn't like fully sure if I should commit to it yet.
Okay, I see. So it's more like maybe less. I would say, maybe practice the drive program a little bit more. But overall, I'm not too dissatisfied with what I saw. I think you understanding the memoization is fine. You just need to get faster at this. That's really all it boils down to.
Yeah. I knew like once I had this n = 0 return 1, I kind of knew like what I had to do next. But it was just because like I mentioned, like even though I knew how to do it, like DP is definitely not something I am very proficient at. So I wanted to kind of be extra careful about it, and I think this pretty much ties back to what we talked about last week about paranoia. And so like I just went a lot slower than I could have.
I'm fine with that if you like. Again, and this just tells me that you're not used to it, which is fine. I'd rather you be more paranoid and testing everything than to be underdo it and then just like miss something. I'm okay with this. But when you are in that state of being paranoid and not knowing what you're not knowing, that usually means you need more practice with something like this.
Okay.
So, other than that, I think I like what I see. I think you just need to, like I said, keep practicing it. And we have like 15 minutes left. Let's go through your schedule, and then I can let you go a little bit early.
Okay, sounds good.
So let me bring that up. All right, and then I'll look at the schedule. Okay, study plan. You're on vacation.
Are you sharing your screen?
Oh yeah, let me share it. Hold up. Okay, so yeah, so I know you're on vacation, so we're basically gonna say can only dedicate 12 hours, 6 on the week, 6 on weekend.
Okay.
Okay, and so basically what I'm gonna have you do is like read DDIA while you can, like maybe if it's like
Yeah.
you're on
Yeah.
the bus or some shit like that, and it's like, oh, I'm so bored, bust out like a few pages.
Yeah. Yeah. Sure.
And then let's say, yeah, like do the homework, dynamic
Hmm.
programming, and then practice pseudocode, and I would say, yeah, pseudocode and reverse engineering.
Okay. Okay. Do you have any advice or like opinions on like how I should practice greedy if I do have extra time?
Do the problems. Honestly, greedy is just a tactic. It's like, hey, to me, greedy, it shouldn't even be its own category. It's literally, what's the smoothest brain idea I can come up with that seems like it's gonna work. That's all greedy is to me. It's not even its own what's it called? It's not even its own category, at least for me. So that's what I see.
Because every time I look at a solution that's like greedy, I like it just doesn't make sense how they got it.
Okay. Yeah, I would say then if you can practice some greedy.
Okay.
Other than that, I think that's basically gonna fill up all your time. And then next week we can start on some system design and split our time between leak code and design. But yeah, I think you go at this rate 1 or 2 weeks, you might be ready for coding interview. So I would be reasonably. I think at this point I'm giving you like a 50-50 for passing. I want to get that up to at least 80 on phone screen.
Okay. Okay.
So I would say
Okay.
if you have to give your recruiter a exact date, I think we're still push that back by. We might be able to make the 14th, but I would say it's closer to like the 19th. But
Okay. At least for the Amazon one, I know I can schedule it a lot back. She told me to give her 5 dates after the 16th, but I'm planning to give her like some dates in like after Thanksgiving.
That's fine.
And
So
she's
Amazon
okay
is
with
your
it,
only. Let me look at your sheet again. We want to. You're aiming for the L4 conversion at Facebook. So let's use we're gonna use Amazon as practice as our first litmus test. And once we get like a green light on that, then we'll book G, and Facebook.
Okay.
So so let's book that Amazon one. We want an early signal. Let's book that for, you said 5 days after the 16th, right? So let's hit that on the 21st. Because I know
she told me to give her 5 dates after the 16th, but it doesn't have to be 5 days after.
What do you mean after? What do you mean after the 16th?
She just told me to give her like 5 days of availability after the 16th, so I guess like she could choose from based
So
on
it
the
could be like
interviews.
17, 18, 19, right?
Yeah, or it could be even like she didn't mention how far I could put it out.
Okay.
So
Got it.
yeah.
Okay, so so your interview is going to be after the 16th anyway, so.
Yeah.
So that's fine. That's fine. Okay. That gives us some breathing room. Great. Then let's aim for the 21st. So what? So
Okay.
wait, your phone's going to Google on the 10th?
Yeah, that's what we talked about last week, right?
Oh, okay. Oh, wow. This is really bad, actually. Holy shit.
Yeah, and I did ping the recruiter today, and she did say it's best if I could commit to it, unless it's like a really like an emergency.
Well, okay. I'm going to tell you this. How badly you want to do well on that phone screen is up to you, and how much of your vacations you're willing to give up. I can't make that decision for you. I can only help you. How badly you want this, how badly you want this is up to you, man. So,
no worries. I know it's totally not up to you, so it's fine.
Okay. Anyway, let me know how things go, but I think I'm gonna let you off with this. Get your dynamic programming down. Get the practice pseudocode and reverse engineering. Next time I see you Thursday, I want you to actually show me a video of you doing a dynamic programming problem from EPI, if possible.
Okay, dynamic programming from EPI. That's good.
If that exists. If not, then do another recursion problem.
Okay. I'm just gonna write that down.
Yeah. Okay, and then when you come back, I want you to spend the 6th, 7th, 8th, 9th. Yeah, we have 6th, 7th, and 8th, 9th together. So we're gonna hit that really hard. I'm gonna try to like really grill you on those 4 days. But yeah.
Okay.
For now, like try to balance some DP, some recursion, and get really comfortable
Okay,
with recursion.
okay.
I'm like, one thing I want to point out that I didn't quite point out before was I feel like you were
Yeah.
hesitant on using recursion in the serialized deserialized problem was because it didn't feel like you were actually comfortable with it. So just as a really quick tip, like for recursion,
Yeah.
like you can like it's basically a function call. It's gonna be like foo. Let's call it recurse, right? Recurse x.
Yeah.
And then result, right? Result, and then process result. Let's just say result. You can do this, or you can do it afterwards, right? Or you can do process here, and then recurse x, and then results, and then after that you can just do like whatever. It's just a matter of like prepend or postpend, whatever you rely on. And in general, if you are relying on the result to come back to do something, you should pretty much go with this. If you're not reliant, then you can just kind of do this. Does that make sense?
Okay. And process result here is not necessarily a function, right? It's just me doing additional
It's
computation.
doing something. For all I know, it could just be like print ln result. It could easily just be this.
Okay.
So, but
Okay,
if you're
okay.
reliant on the result of the children coming back first, this is like the order in which you should do things.
Okay. That's gonna be helpful.
Yeah, just remember that one tip and then see if that makes a difference. But yeah, otherwise, I want you to do the homework. I think that's 12 hours of work right there. Any other final thoughts?
Okay. No, I think that's good.
All right, then I'll let you off early.
All right. Have a good one. Appreciate
All
the
right,
time.
Bye-bye.
All right. Bye.
All right, so with that, I'll take questions from the crowd if there are any. Well, going once, going twice. Well, all right. Thanks for watching, guys. We will have a stream tomorrow, and we will have a stream on Thursday as well. So tomorrow will be 8 p.m. PST, and then Thursday will be the replay analysis at 9 p.m. PST. So I hope you guys stick around for that, and have a good night.